Last week we started talking about the idea of problem decomposition, and that's the idea of having a big task that we want to accomplish and breaking it down into a bunch of pieces. And we did this using a couple different pieces of software. We used shortcuts on our phone, we used if this then that on the web browser, and then some of us used Automator on our computers to build some automations that again accomplish some things using these individual tasks. We're going to get a little more into the code this week. These blocks of code are called functions. And so I'm going to refer to functions as these self-contained blocks of code that have a specific purpose. Breaking a big task down into functions is sometimes the first thing that you do when you're trying to build a piece of software. Another important thing to consider is that functions are blocks of code that can return or store a value to be used elsewhere in the program. And so when we were doing this with shortcuts, we asked the user to enter an amount of time, and that amount of time was used later in the program for setting a timer. Now, a piece of code or a function doesn't have to store a value. It doesn't have to have any inputs at all. It might just perform a task. So it might have no inputs and no outputs. It could have no inputs and it could have an output. For example, you might run a piece of code that asks your computer to just tell you what time it is. It's also possible for a function to have multiple inputs and just use those inputs to do something and not have an output at all. And you could have a function where there are multiple inputs and there is an output. And you might wonder, can we have a function that has multiple outputs? And most of the time, for what we're going to be doing, the answer is no. It is possible to have an output that is a single variable, and that variable can have a bunch of things stored within it. But for the most part, we're not going to be talking about functions that have multiple outputs. I'm throwing a lot of vocabulary at you today, and so here's another one. It's the idea of calling a function. So right here on the screen, I have the definition of a function called wait a second, then screen. So you can see I've defined the function. Usually that has the name of the function. That's what comes before the parentheses here. And then there are usually some grouping symbols that are used to show what is the code inside of this function. And so for this code, and the code that we're going to be using today, which is the language JavaScript, we use braces to group code together. So that defines the function, and that's the function definition. But you also have to call the function if you want your program to run the code inside of it. And so you can see here that I am calling this function, wait a second and then screen, twice. So if I were to actually run this, it probably would look a little bit like this. Ah! Ah! Very simple. It's possible for a function to have inputs and outputs. And this is what it looks like when you're actually using JavaScript. So you can see that there's an input inside the parentheses of the function. That's where you put the inputs to a function. Whatever variables you want to bring into the function are usually inside the parentheses. And you can see that this function has an output. We know this because it has a return statement. Anytime a function has a return and then a variable, whatever is after that return keyword, that is the output of this function. And so you would expect a function like this to have different outputs based on what you put into it. So you might say, for this particular function, find the number of people in this room. And so that might be 20. If you make the input the entire school, that number is obviously going to be much bigger. So the output depends on the input that you put into these functions. So here's another function that has no input. And where you call a function actually matters a lot. Because you can imagine, if I take this function and I were to call it here in our classroom, I probably would be the one that is returned because I'm the oldest one in this room. If we were to do this instead in the high school office, where we have people who are older than me, let's say Dr. Choot would be returned. Because there's no input though, the output is going to depend a lot on where we call that function. This is an idea called scope, but we don't have to worry about it so much now. I just want you to start thinking about this idea that where you call a function does matter. The last thing we may want to do is be able to document what a function does. And so these are the 4 things that I'm going to be asking you to determine for some of the functions that we're going to be working with. You should be able to identify the name of the function. You should identify the input or inputs that that function has. You should also be able to identify the outputs, if there are any, which is something you can figure out from the return statement. And the last thing that you want to be able to do inside the function is understand a little bit about how it relates an input to an output. Those steps are often known as the algorithm of the function. And so being able to identify exactly what that function does is going to be something that we're going to learn to do over the course of this year. So in the next video, we're going to start looking at a specific program that I've written, and we're going to think about it in terms of trying to identify this information about the function. So what is the function name, inputs, if any, outputs, if any, and what is the algorithm that goes on inside of it.